Take a moment. Look up. Everything you see, the stars, the moon, the glowing band of the Milky Way, is part of a story that began almost 14 billion years ago. A story so vast it gave birth to time itself. This is the story of everything, of how something emerged from nothing, and how one day it might all vanish again. So let's go back, all the way back, to the beginning of everything. Before there were stars or galaxies, before atoms, before light itself, there was nothing, or at least something that looked a lot like nothing, a tiny point, smaller than an atom, denser than anything we can imagine, containing everything that would ever exist, compressed into a single, unimaginable dot. And then it expanded. Not like a bomb exploding into space. There was no space yet. It created space as it expanded, stretching reality itself outward. We call that moment the Big Bang. It wasn't an explosion in space. It was the beginning of space. In less than a trillionth of a second, the universe went from microscopic to cosmic, expanding faster than light, filled with raw energy, a searing soup of particles and antimatter fighting for survival. Tiny ripples, minute differences in density, would later become galaxies, stars, planets, and us. But right now, the universe was chaos, a storm of creation. At roughly 3 minutes old, the first atomic nuclei began to form, mostly hydrogen, some helium. This is known as Big Bang nucleosynthesis. No atoms yet, just nuclei, bare protons and neutrons floating in a wild sea of energy. Then, after 380,000 years, a calm. The universe cooled enough for electrons to slow down and join with nuclei. For the first time, actual atoms existed. Light could finally travel freely, a cosmic curtain lifting. That ancient first light still fills the universe today. The cosmic microwave background, or CMB. A faint glow of microwaves coming from every direction, the echo of the Big Bang itself. We've mapped it. It's the image of the universe when it was just a baby, a few 100,000 years old. Darkness lasted for a long, long time after that. The universe was full of invisible hydrogen gas, slowly cooling, slowly clumping together under gravity. Then, perhaps a few 100 million years later, some of those clumps collapsed so tightly that their cores ignited. The first stars were born. Massive, hot, brilliant blue giants. They lived fast and died young, exploding as supernovae and seeding the universe with heavy elements. Every carbon atom, every oxygen molecule, every piece of gold, all forged in the hearts of those early stars. And as stars gathered under gravity, they began to form the first galaxies, vast cosmic cities of stars. Over billions of years, those galaxies merged, collided, and evolved. Spirals, ellipticals, dwarfs, all dancing through the cosmic web. Our own Milky Way was one of them, a grand spiral with hundreds of billions of stars, rotating every 230 million years. Our sun is a newcomer, born just 4.6 billion years ago, in one of those spiral arms, from the ashes of older stars. From those ashes came Earth, and from Earth came life. If you could zoom way, way out, beyond stars, beyond galaxies, you'd see something extraordinary. The universe isn't random. It has a pattern, a cosmic web. Galaxies form along vast filaments of matter, bridging across empty voids like strings of light. At the intersections, enormous clusters of galaxies, bound together by gravity. It looks a lot like a neural network, Or maybe a gigantic cosmic brain. How does all that structure hold together? We can see the galaxies, but something unseen gives them shape. Something massive, something invisible. We call it dark matter. Dark matter, the ghostly, invisible backbone of the cosmos. We can't see it, we can't touch it, but we know it's there because of the way it tugs on everything else. Galaxies spin too fast for the stars inside them to stay bound if only normal matter existed. If it weren't for something invisible adding extra gravity, those galaxies would literally fly apart. That invisible mass, dark matter, acts like cosmic scaffolding, shaping galaxies, binding clusters, holding everything together. Roughly 27% of the universe is made of dark matter, and yet we still don't know what it is. It's not atoms, not light, not anything in the periodic table. Some thinks it's made of exotic particles, WIMPs, axions, or something even stranger. Others wonder, maybe we've misunderstood gravity itself. Whatever it is, dark matter keeps the cosmic web intact. Without it, there would be no galaxies, no stars, no us. But that's only part of the mystery, because if 27% is invisible matter and 5% is the normal stuff, then what's the other 68% of the universe made of? That leads us to something even weirder. In the late 1990s, astronomers studying distant supernovae saw something unexpected. The universe wasn't slowing down, it was speeding up. That didn't make sense. Gravity should pull everything back together. But instead, something was pushing galaxies apart, making space itself expand faster and faster. We call this strange phenomenon dark energy. No one knows what it really is. It might be a property of space itself, some kind of repulsive energy woven into the fabric of the cosmos. Or it could be a new force, a dynamic field that changes over time. Either way, it now dominates the universe. When we speak of the universe, remember, most of it is dark. Not in the sense of shadow, but in the sense of mystery. Dark matter holds it all together. Dark energy tears it apart. And we, tiny creatures made of atoms from ancient stars, stand between those cosmic forces, trying to understand the story of it all. So, what happens next? How does the story of the universe end? Scientists have a few theories, each one poetic and a little terrifying. If dark energy keeps accelerating the expansion, galaxies will drift farther and farther apart. Stars will burn out. New stars will no longer form. The night sky will slowly go dark until even the last red dwarfs fade. In trillions of years, black holes will evaporate, leaving only cold matter and fading light. Eventually, even atoms might decay. A universe of nothingness, silent, frozen. That's the big freeze, the slow death of everything. But if dark energy grows stronger over time, something even wilder could happen. The expansion would accelerate so violently that galaxies would tear apart, then solar systems, then planets, and finally, even atoms themselves. Space itself ripped at the seams. That's the Big Rip, a universe literally torn to pieces. Or maybe, one day, dark energy will weaken and gravity will take over, and the universe will reverse its expansion. Everything rushing back together, galaxies colliding, stars merging, temperature rising, until the universe implodes into a singularity again, a huge collapse. That's the Big Crunch. And maybe, from that collapse, a new universe could be born. A cycle of cosmic rebirth, endless explosions, endless beginnings. We don't know which one is true, but they all tell us something profound. Everything changes, even the universe itself. When you step outside on a clear night, you see faint light that has traveled millions of years to reach your eyes. Some of those stars no longer exist. Their light is a memory. Every moment we look up, we're literally looking into the past. And every element in your body, the iron in your blood, the calcium in your bones, the oxygen you breathe, was forged in ancient stars and scattered across the galaxy by their deaths. We are the universe becoming aware of itself, stardust that learned to think, matter with consciousness wondering where it came from and where it's going. Every discovery, from the Big Bang to dark energy, is a small step toward understanding our origins. And maybe that's what the universe wanted all along, to be understood. The universe began in a flash of creation. It evolved through chaos and wonder, through birth, death, and infinite change. Now, billions of years later, we are here, brief sparks of consciousness floating in the vast dark, trying to make sense of it all. Maybe that's our purpose, not to control the universe, but to witness it, to love it for its beauty, its mystery, its impermanence. From the Big Bang to the last fading photon, the story of the universe is also our story. We are part of the beginning, and someday we'll be part of the end. So when you look up at the night sky, remember, you're looking at history. You're looking at home. Because the universe isn't out there somewhere. It's in here, inside every atom of your being.